Hi guys, Shouvik and welcome back to our YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have this problem. Find the lexicographically largest strings from the box one. Yeah, so this problem tagged as a medium and I feel so it's like medium only kind of problems. Based on the time and space complexity they have allowed to going to be it's accepted, then based on that it's obviously a medium problem for sure. So easy medium kind of problems. Yeah. So they have given a string word and an integer num friends. Alice is organizing a game for her num friends. There are multiple rounds in the game, where in each round word is split into num friends non-empty strings such that no previous round has had the exact same split. Just for like making yourself in confused state, so they have written like too much things, and all the split of the words are put into a box, and the splits that you have make, so you have a word, so on high levels what actually they are looking for. Let me just explain to you guys in some simpler term. So what actually we have it on this particular problem, so they have given a word A, B, C, D, E. Let's suppose this all are lowercase English letters. Now let's suppose you have three friends. So how many, if you want to like split this complete words, so that is our words, if you want to split these words to your three friends, then how many partition you have to create? So you can do two partitions, one here, and my string is divided into three subset. Agree guys? So like this way they have asked to make all the, like you can do any all the partitions you can do, like any combinations partitions you can do, but the last partition should not be like same as the partitions you are doing. So let's suppose if you done a partitions this at, let's suppose 0.1, then you are not allowed to do the same partitions CD, AB and this E. This is not allowed. Let's suppose at 0.5 you are doing, so this is not allowed because we have already performed it at step 3. Agree? Now what they are looking for, now they are asking for if so this way they have asked to do the partitions. Now if we can go to the problem statement, I think last line is pending, what they are basically looking for. So find the lexicographically largest strings from the box after all the rounds are finished. So you can play your strings like A, B, C, D, E. You can do the partitions, either here or and here. So it is divided into three groups. Right? It is divided into three groups. Now there are other options also. A, B, C, D, E. You can do a partitions here and a partitions here. Then this and this is the group. Yes, agree. So now what actually they are looking for? If we are doing the partitions in such way, what is the, so you can do like this way. You can find all the partitions you have done, and out of the partitions, what is the lexicographically largest partition word that you are able to build, right? So now I think you guys know about lexicographically largest. So let's suppose if I am considering two strings of same length, and if let's suppose it is ABC and it is BCA, right? So in two same length strings, I am going to consider the string which is lexicographically largest, in which I will iterate from the very first index, and at which index they are differ. The index that they are differ, on that index which value is higher? A is higher or B is higher? My B is higher, so it is lexicographically largest. So let's suppose my string is ABC and another one is ABZ. Then AA same, BB same, CZ not same. Who is lexicographically higher? This one is lexicographically higher, right? So this should be my string. So this should be my strings. Got it guys? So that is of lexicographically largest strings. Now if this things is given to you, so you can, what is our initial strings? A, B, C, D, E. Let's suppose this. So what is the length of it? Let's suppose its length is 1, 2, 3, 4, 5. Its length is 5. Yes, its length is 5. And if we are looking, we have to split it. We have to split it into how many friends? Let's suppose two friends. So on the constraint also you can see your friend count is always within the boundary of word length. So that is always valid, and your word length is 5 into 10 cube, and word consists only of lowercase English letters, right? So now if we can go to our OneNote, so let's suppose if you are super greedy, I know, you have to look for lexicographically largest strings. I know you have to look for lexicographically which strings? Lexicographically, tell me guys, tell me. We have to look for lexicographically largest strings. We have to go for, what happens to it? Why it's being smaller? What I have done here? Okay, like this. No. On 3 dot, if I'm going to click it full screen. So now I always have to be, now there is one more case. So if suppose my first string is ABC on lexicographically only, and this is of ABZ. So out of them all are till this all are cancelled, all are same. So now on this it has an extra then, and it has nothing. So on that case I will consider this as an lexicographically largest. So that is the funda of lexicographically largest. Now I know I have to find the largest strings. In which distributions a particular friend I will try to create one partitions in which it will going to get the largest size. And what is the largest size? Considering I have to allocate everyone's to be one, at least one word, one character for sure. So I can assign one of my friend to this character, another friends to this character, and all of the rest CDE to another friend. So it is the largest size. So what is the largest size length then? Can you guys tell me what is the largest size length? So if there are two friends, if there are two friends only, sorry I missed it. So if there are two friends, then you can assign this A to only one friends, and then B, C, D, these complete sections A, B, C, D, E, and you have two friends. So you can assign this A to one friends, and this B, C, D entire pair to another friends. So on the largest partitions, that is of B, C, D, what is the size of it? Can I write it? It's nothing but, what is the total size? The total size is n. And what is the number of friends? So there is only two friends. So I will minus 2. Then, so this n is nothing but 5. So 5 minus 2 is 3. So plus 1. That is a 4. Let's try one more. Let's suppose I have Z, A, P, Q, R, S, N. So my n is in this case how much? 1, 2, 3, 4, 5, 6, 7. And let's suppose I have friend equals to 5 friends, right? So I will assign 1 to this, another 1, 2, 3, 4, and the last one I will assign the entire 3. So what is the largest size? If I am going to apply n minus friend plus 1, that is of 7 minus 5 plus 1, that is of, tell me, 7 and 2, 3. Yes, I am getting. So I am getting the largest window size in which, so I am giving the intuitions, guys. Please focus on this particular point. So I am getting what is the largest window size we can get. Yes, the largest window size, or the allowed, or the max window size that we are going to get with this allocations is nothing but n minus friend plus 1. That is the largest window size. Yes. Now is this problems now is a very simple problem. Now what you have to check? You have to check the group of this window size. This is your constant window size. You can check on this constant window size, that is of n minus friend plus 1. You have to check for every constant. So how you can write it then? So what should be the pseudocode then? For I in range n, you can check for what is your. So you can start with a max code. That is initially you can assign to be a empty string, and if what is the current window you are considering? You are considering from our word of current index to index plus max window size. So that is the window you are considering. If this code is higher than your max code, can I store it? This, my max code is nothing but this word of I to word of I plus, tell me guys, I plus max window size. I can store it. Yes, I can store it. And finally just do it. Yes, I will update. And finally, if we are going to return our max code, if it work, yes, that is the problem. Just 1 to 2 liner. So now maybe some of you guys don't know how actually this comparator functions in Python is working, but every language has its own string comparator functions. So you can write your own custom comparator functions. You can write your own custom comparator functions. You can pass one string that is of word of index to index plus max window size, and you are going to pass another of max code, So this custom comparator is going to consider this particular strings is higher than your max code when. So it going to be very simple. I have used the custom comparator only, but like inbuilt function only, but you can write on your own also. I and j you can start with from 0,0, and your nn and should be like len of 1 for this word, and like your word that is passed, and another one is max code length. So I guess you guys are getting now your I should be less than your nn, and your j should be not less than equals to less than your If these two conditions hold, if these two conditions hold, I should be less than of nn and j should less than of then you are going to iterate. If your how should be, if your word of or the first strings that you are going to get, if I am going to write it in current, if the current word of I is greater than your current word of your max word of or max code of j, then though this guy is higher, then you can return a true. So we need to update. elif tell me guys, if your this is smaller, like right, this entire things is smaller, then you can return a false. If both are same, then on that case you don't have choices. You have to go for further I plus plus and do a j plus plus. That's it. And finally, if let's suppose you are out of the this particular while loop, that is of while I less than nn and j less than then you are going to check if you are going to exhaust. If you are going to exhaust with the max code on max code, and the current has everything similar, but max code has exhausted but current has more, then if you are going to check if your I is still less than your nn, then that means max has exhausted. Then on that case you can return a true. That case we have just saw. If you have exhausted by your j less than that is we have exhausted with the current, then on that case my max is still higher. Right? Yes, these two would be the only cases, or in any other cases you can return false. No other case should be possible, but you for safer side return a false in other cases. Yes, you can write your custom comparator, but every function is actually doing this custom comparison. So I have used the custom comparator only, like inbuilt comparator only, but the custom comparator code, how actually it is working, I have given you a high level overview, or actually the pseudocode, it's working exactly, that's it. It is just following two pointers approach, or if you've done merge sort kind of things, then it is like mostly a cakewalk for you. So it is basically checking in pointer by pointer of both the current and the provided max code. So it will do the same. So I have used the custom comparator only. Yes, so now we can quickly discuss the code iterations we can complete. The code is as crisp and as small as that, guys. So I have start with my if my number of friends is 1. If there is only a single friend that is on myself itself, then I will going to take all the words. Correct. Then there is nothing to do. Otherwise, I have stored my n to be len of words, max code, max window size to be max code is empty, and max window size is nothing but n minus num friends plus 1, n minus num friends plus 1. Now we are doing standard for I in range nm. If word of I to I plus max window size, that is this window we are considering, if it is more than my max code, then on that case stored your max code to be word of I to I plus max window size. So we are going to store it, and finally we can return. On inside this, there is a, you can write, maybe interviewer are going to ask you to write your custom comparator functions of taking two strings and just basically return a true false here. So that I think is kind of a very childish things. We have already done the one note of this two pointer things that you should be able to do on the interview if interviewer is basically looking for that. But apart from that, the problem is on high levels is as simple as that, guys. Yes. So now we can quickly discuss the time complexity. Now can you guys predict on your own the time complexity? We are doing a single iterations for I in range nn. So it is of big of n, which is completely wrong. If you are going to state it in big of n on interview, it's completely wrong, because we are doing a slice operations we are using. So slice operations itself is going to take a big of n. And here also you are assigning. So either you are assigning or not, you are basically slice the word from I to I plus max window size, right? That is, this operations is altogether going to take a big of n for sure short. And what is your max window size can be on that case. What is the max window size? Max window size is going to be, tell me guys, tell me, quickly tell me guys. So n minus num friends plus 1. If num friends is 1, then 1 gets cancelled, is as big as max window size can be as big as n only, as big as n only. Correct. So this can grow as big as n, and inside that this comparisons also working in kind of big of n only, and if assignment is needed, then also it's kind of big of n. So it is inside this it is a kind of big of 3n kind of solutions, but you can write it in kind of big only. So the outer for loop is running for big of n, and inside that there is a 3n complexity. I'm writing it in big of n only. So it is a big of n square kind of complexity for sure. It is of quadratic complexity. And are we good with the quadratic? Are we good? Yes, we are super good. It is of 10 cube only. So my complexity is going to be 10 raised to the power 6 into 25. That is 2.5 into 10 raised to the power 7. We are far good because we are allowed to do 10 raised to the power 8 operations. And the space complexity is definitely going to be this max code size. I would suggest you definitely have to consider, because you are returning to the answer. So your maximum this max code storations is as big of n, but we are altogether using it to return. So you can tell explicitly to your interviewer that you need it to return the answer, but let's consider, because you have to store it somewhere, then only you are able to return, right? So the space complexity is big of n, and this is bound to be the most optimal time and space complexity that I am able to think of for this particular problems, and I'm pretty sure like it is indeed the most optimized time and space complexity that going to be possible altogether for this particular problems. And if you can see also, right, my time complexity is kind of 85% faster than all the submissions over the Leetcode. It is of big of n square, but that is what they are looking for. So it is 85% faster, 90% faster than all over the submissions happened over the Leetcode. And on space complexity also, you can see we are on 100% beat of all the submissions over the Leetcode, because we are using only the big of n space only for return the answer, big of n space only to return the answer. So space perspective, we are super good. There is no chance to beat us in space. And time complexity also, it is bound to be the most optimal big of n square solutions for this particular problem. And that's it guys for this particular problem. And if you guys are able to understand till this point, so I guess you guys are already doing so, please do subscribe to our channel, and please share the videos to your friend circle who are also preparing for top product based company and brushing up their DSS skills. And please turn on the notification so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.